Welcome to all of you. Today we discuss practical number 10, LU decomposition method to solve a system of n linear equations with n unknowns by C programming. First, we discuss about this preliminary discussion about the method. This is the system of n linear equations with n unknowns. Actually, we here n equal to 4, set n equal to 4, then ax equal to b is a system of uh, 4 linear equations with 4 unknowns x1, x2, x3, x4, and let this LU equal to A, the coefficient matrix A. Here L equal to L11 0 0 0, L21 L22 0 0, L31 L32 L33 0 0 0, L41 L42 L43 L44. This is the lower triangular matrix L, and this is the upper triangular matrix U, and all principal diagonals in the upper triangular matrix are all 1, and other elements are 0, and this is the upper triangular matrix, this U12, U13, U14, U23, U24, U34. So when you multiply this matrix multiplication row by column, then this first row, this is the first column, so we get this L11 element, and this element, this equal to A, so this equals to L11 equal to small a11. The capital A is the coefficient matrix, so a11, a12, a13, a14, a21, a22, a23, a24, and so on. Next, this first row, second column, so L11, L12, this is the A12, so this is the element A12, L11, U12 equal to A12. And so first we multiply these matrix L and U, and we get this matrix, this 4 by 4 matrix, and which is equal to the coefficient matrix A. So this is the elements A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, and this is the A41, A42, A43, A44. And this is the elements, and comparing with the coefficients corresponding elements, and we get this is the red letter. We have to determine this red letter. So from this column, first column, L11 equal to A11, L21 equal to A21, L31 equal to A31, L41 equal to L41. So obviously that is the Li1 equal to AI1, I equal to 1 2 3 4, because we set here n equal to 4. So from this first column we get the all L11, L21, L31, L41. And next this red highlighted uh, uh, row, this is the row. From this row, L1 to L21 equal to A12, L11 U13 U13 equal to A13, L11 U14 equal to A14. And from these equations we get U12 U13 U14. So U12 equal to A12 by L11, U13 equal to A13 by L11, and so we compactly write U1j equal to A1j by L11, and j runs from 2 3 4. When you put j equal to 2, we get U12, j equal to 3, we get U13, j equal to 4, we get U14. So from this row, this row, part of this row, first row, we get U12, U13, U14. And next, second column, part of this second column, this part, from this part we get this. So from this part, comparing with the coefficient matrix A022, A32, A42, we get L22, L32, L42. and compactly write Li2 equal to Ai2 minus Li1 into U12, and I runs from 2, 3, 4. And this is the second row, part of this second row. From this we get U23 and U24. So this is the L21 U13 plus L22 U23 equal to A23, and L21 U14 is equal to A24. So from these elements we get U23 and U24. So U2j equal to A2j minus L21 into U1j whole divided by L22 when j equal to 3 and 4. And from this third column, part of this third column, we get L31 equal to this equal to A33, and this equal to A43. And from these elements, from these equations, we get L33 and L43, and we write here Li3, I equal to 3 and 4. And lastly, we get from this uh, third row, part of this third row, this part, you get U34, and this last element L44, we get L44. And compactly we write this first this Li1 equal to this, U1j equal to this, and this Lij that is the Aij minus Li1 into Ui1j plus Li2 into U2j plus dot 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 Lij minus 1 Uj, this is the Uj is the third bracket, this Uj minus 1 and j, that is from this equation actually we get L22, L32, L42, L22, L32, L42, and we get L33, L43, and this is the L33, L43, and lastly we get L44, and this is the L44. So this block, from this block, these blocks, we get this L22, L32, L42, L33, L43, L44 when I greater than equal to j. So when I equal to 2, j equal to 2, I equal to 3, j equal to 2. So always here I greater than or equal to j. So by this equation we get this these elements, we get these elements, these elements, and these elements L33, L44, and L44. And next by these equations, this equation Uij, actually we get here U23, U24, U34, U23, U24, U34, and we write when I less than j. Here obviously 2 less than 3, 2 less than 4, 3 less than 4. So we get this compactly, we write this equation from this equation, this U44, this is the from this U44, U 34, sorry, L4, sorry, U34, the red highlighted letter, this from this. So from these settings we all elements we get all elements of this lower triangular matrix and upper triangular matrix. All elements are known from this calculation. And next, this lux equal to b, because a equal to lu, so obviously lux equal to b. And let a ux equal to y, ux equal to y, so obviously ly equal to b. So L means this lower triangular matrix, Y means Y1, Y2, Y3, Y4. This equal to B, B1, B2, B3, B4. And again solving this, we get this first row, first column, this is the B1, second row, this first column, this is equal to B2, and we solve this equal to this. Y4 equal to this, and hence compactly we write this yi equal to bi minus bracket li1 into y1 plus li2 y2 plus dot dot li I minus 1 yi minus 1 bracket close divided by whole divided by lii. here I equal to 2 3 4. So we get y2 y3 y4, and y1 from y1 we get from this equation y1 equal to b1 by l11. So from this we get all these y1 y2 y3 y4. And next uh, we have ux equal to y. So u equal to the upper triangular matrix x equal to x1 x2 x3 x4. We have to determine the values of x, and this is the y. Already we have determined y in the previous section, and also we have determined this upper triangular matrix u. So unknowns are x, easily can be easily determined from this set of equations. This actually this is the back substitution. This from this first row, this column, first column equal to y1, second row, second column equal to y2, third row, third column equal to y3, and this fourth row, first column equal to y4. Actually here we use the back substitution, this x4 equal to y4. So we get this, and then x3 plus u34 x4 equal to y3, and from this we get x3 equal to this y3 minus u34 into x4. So obviously we get x4 equal to y4, and others 3 to 1 we get this equation. Compactly we write this xi equal to uy minus ui into I plus 1, xi plus 1, ui into ui I plus 2, xi I plus 2, and dot dot ui4 x4. And we completely solved the system x1 x2 x3 x4. Here we solved the system of 4 equations and 4 unknowns for uh, understand for understanding the system LU decomposition, Crowd's LU decomposition method technique. Now come to this programming. This is the LU decomposition method. This is the problem 10. Write a C program to find the solution of the following system of linear equations by LU decomposition method. This is the system of equations. This p equal to r plus 1 by 10, and this. First, we two-dimensional array we use here. A, the coefficient matrix 10 10. Actually, this A 10 10 means that A 0 0, this is the first element, A 0 0 to up to A 9 9. A up to A 0 0, A 0 1, A 0 2, up to 0 9, and so on. This U 10 10, Y10 is the one-dimensional array, X10 one-dimensional array, and B10 is also one-dimensional. Only there are three elements, three these A, L, and U are two-dimensional arrays. Now integer variables are I, J, K, N. Here we this the given problem is 4 by 4 matrix. There are 4 linear equations with 4 unknowns. So system here n equal to 4. We here set n equal to 4 order of the coefficient matrix here. If you want to desire these the elements term by term, yourself by yourself, so you can write this scanf, enter the order of the n, scanf n, printf, enter the element row wise coefficient matrix, this is the aij, and print enter the right hand vector, that is the bi. So you can delete this portion from this portion to this portion, because here we write here the explicitly these elements explicitly. Integer r, this is the last digit of your roll number, enter the value of r, the can scanf, this percentage d ampersand r, float p equal to r plus 1 by 10 according to our problem, to the given problem p equal to r plus 1 by 10. And the elements are this a11, this is the actually here you can write a00, but for similarity to our theory, this is the theory, we use here this l11, actually a11. So we write here actually some modifications here, actually in place of a00 we write here a11, we start from a11. You can also write a00. So a11 equal to 5.1 plus p comma, and separately we define this is the row wise element a12, a13, a14, a21, a22, a23, a24, a31, a32, a33, a34, a41, a42, a43, a44. This. And the right hand column vector column matrix, this b1, b2, b3, b4. These the all are separated by commas, but in the last step this is the semicolon. Careful that this is the last before value of before the last entry. This is the semicolon here, put here semicolon. Now compute the matrix for I equal to 1 to I less than equal to n I plus plus. That is Li1 equal to Ai1. From this calculation we get L11, L21, L31, L41. Actually we write this from this is the first element, this Li1 equal to Ai1, I equal to 1 2 3 4. So we get here this L11, L21, L31, L41 from this for loop, from this for loop. Next, for a j equal to 2, j less than equal to n, j plus plus, u1j equal to aij divided by L11. You get from this u12, u13, u14, u12, u13, u14. So u12, u13, u14. So you get this compute this u1j, a1j, l1j, j equal to 2 3 4 from this for loop. Next for loop, I equal to 1 to this I u1 uii equal to 1. Actually this is the upper triangular matrix, the principal diagonal elements are all 1. So u1 1, u2 2, u3 3, u4 4 equal to 1. And this is the upper triangular matrix. This is the principal diagonals u1 1, u2 2, u3 3, u4 4 are all 1. So you put here uii equal to 1 for all I. Next for I equal to 2 to I less than equal to n I plus plus, and next for loop j equal to 2, j less than equal to n, j plus plus. If I greater than equal to j, lij equal to aij, and for k equal to 1, k less than equal to j minus 1, k plus plus, lij equal to lij minus lij star ukj. And from this loop you can easily calculate this L22, L32, L42, L42, L42. Here I greater than j, so he obviously greater than equal to j. So 2 greater than equal to 2, 3 greater than 2, 4 greater than 2, this 3 equal to 3, 4 greater than 3, 4 equal to 4. So these elements can be calculated from this simplification, and they so you get this uh, from this the equation, this lij aij. Actually we write here this l, this element, this l and this l, this l and this l. Actually compactly we write lij equal to aij minus li1 into u1j, li2 u2j, and so on so on. So we calculate this first I equal to 2, I equal to 2, and runs j equal to 2. So first I equal to 2, j equal to 2. Now so here I equal to j because 2 equal to 2. So here L22 equal to A22. L22 equal to A22. Now for k equal to 1, next this inner loop, this k. So L22 equal to L22 minus L21, and k runs up to j minus 1. So here j equal to 2, so j minus 1 already, so only up to run k equal to 1, k equal to 1. So here only one step here, L22 equal to L22 minus L22 minus L21 into U12, U12, U12. So this is the elements L, this is the element, this L22 equal to A22 minus L21 U12. You get these elements first for this, for this loop. Next again go to this j equal to 3, I equal to 2 but j equal to 3. So j equal to 3, this I 2 j 3. So obviously I is less than j. So you enter this loop, else loop I less than j. So here this in the enter this loop. So you calculate here e23, I equal to j equal to 3. Enter in this loop. Enter in this loop. Here u23 equal to a23 And again for k loop, k equal to 1 to k equal to 1 minus I minus 1 k plus plus, that is equal to u23 equal to u23 minus l 21 into u13 u13, and k runs up to I equal to 2, so 2 minus 1, that is 1, so only one element is l23, so you get this l23 l sorry u23, u23, actually here is first element u23 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 is this is u23 u2j, j equal to 3, this u23 minus l21 into u13 whole divided by l22, so you get this element l23. Next, loop this j equal to 3, j equal to 4, so here I equal to 2, j equal to 4, so I equal to 2, j equal to 4, so it is false, 2 greater than equal to 4, so enter in this else loop, and this u24, that is you get u24, you calculate this u24, u24, and u24, so is the get u24, so u2j equal to j equal to 4, so you get that element u24 by this relation, this. And in this way you can get all these elements u23 u24 u34, and from this loop u l22 l32 l42 l33 l43 and l44. Now this is the for interest you can avoid this or delete this, print the lower triangular matrix L and print the upper triangular matrix U. For interest, what is the lower triangular matrix, what is the upper triangular matrix, so print this Lij for I equal to outer loop, for I loop I equal to 1 to n, and the inner loop J, this J equal to 1 to n, and upper triangular matrix similarly uij, and solve this. Now solve ly equal to b by forward substitution. Actually here the forward substitution, this ly, this is the ly equal to b, ly equal to b from this table, ly equal to b, so y1 equal to b1 by l11, and y2 y3 y4 can be calculated this way by this compact form, this I equal to 2 3 4, and so you calculate this y1 equal to b1 l11, and others y I equal to 2, y2 equal to b2, and for j equal to 1, j equal to I minus 1 j plus plus, so you get this y I equal to 2 and j equal to 1, and this 1 minus 1, that is 0, this is 0, so l y2 y2, this is the y2, for this loop, and this, and y I equal to yi by lii, yi by lii, yi by lii, and for I equal to 1, I less than equal to n, I plus plus, print yi, and you can calculate this, and this is the calculation equal to this yi equal to yi minus lij into yj, lij minus yj. Actually this b2 b3 is equal to, here we put here b2 b2 b3 equal to this yi value of yi equal to b, this so first I equal to 2, take I equal to 2, so y2 equal to b2, so here old value y2, this b2, actually this b2, this is the new value of y, this is the old value of y, actually this y equal to b2, and l, this is the 2, and j equal to 1, j equal to 1, l to 1 y 1, l to 1 y 1 y 1, l to 2 l to 2. So you get this ly equal to b, and print this, and next solve this ux equal to y by backward substitution. So backward substitution is this here, so now ux equal to y, so here ux equal to y, so ux equal to y, u is the upper triangular matrix, and this x equal to x1 x2 x3, and y is equal to this, So by backward substitution, we get this backward x values of x, unknown values of x. Xn equal to yn. Actually, this xn equal to yn means x4 equal to y4. X4 equal to y4. And next, put for I loop I equal to n minus 1, xi equal to yi. So n equal to 4. So for I equal to 3. So x3 equal to y3. X equal to y3. Next, this I equal to 3. So x3 equal to this x3, old x3. Actually this is the y3 minus u3 3j plus 1 I plus 1, that is equal to 4 u3 4 into x4 x4 x4. So you get this result. This is the u x3 equal to y3 minus u3 4 into x4. So you get this. And last, print the required solution is this. Required solution, required solutions is this, printf xi, this, return this, and save, compile, and run. Enter the value of r, this equal to, put enter 7. So this is the lower triangular matrix L. This is the row wise element, row wise, first row, second row, third row, and fourth row are all elements in this are 0 0 0 0 0 0. And this upper triangular matrix, notice that these all are 1 principal diagonal, and below principal diagonal all are 0. And y1 y2 y3 are these elements, and required solutions is this x1 x2 minus 28.56, and this the x4 equal to this. You can easily check by this substituting these values x1 x2 x3 x4 in the given equation. You can for interest you can check this from the given equation. This you can check this solution of this, put here, this equation, given equation 4 by 4 matrix. Thank you for watching this video. You can collect the all C files and Word files in the description box. Thank you.